Okay, so let's start with the next topic, that is correlation. Now correlation, as we know, is the relation between two variables. So let's try and understand. Correlation is a statistical measure that expresses the extent to which two variables are linearly related. Now meaning they change together in a constant rate. It may be positive correlation or it may be negative correlation, or sometimes there is no relation. That is also possible. So correlation is a statistical measure that indicates the extent to which two or more variables fluctuate together. A positive correlation indicates the extent to which those variables increase or decrease in parallel. A negative correlation indicates the extent to which one variable increases and the other decreases. And sometimes there is no relation also. And this can be depicted as you are seeing in the graph. Now, statistics represents how closely two variables co-vary. That means their variation is simultaneously. As one increases, the other decreases, or maybe both increase or whatever. So it can vary from -1, which is perfectly negative correlation, through 0, no correlation, and then +1, which is perfect positive correlation. The correlation coefficient, denoted by R, small r, is a measure of the strength of the straight line or linear relationship between two variables. These correlation coefficient takes on values ranging from +1 and -1. So the correlation falls between -1 to +1. The quantity R, called the linear correlation coefficient, measures the strength and the direction of linear relationship between the two variables. Now types of correlation, it may be like perfect positive correlation, perfect negative correlation, moderately positive correlation, moderately negative correlation, or absolute no relation. So any one of them could be fitting in there, like we have seen, and we can see on the graphs also. Now if x and y have a strong positive linear correlation, R is close to +1, and R value of exactly +1 indicates a perfect positive fit. Positive values indicate a relationship between x and y variables, such that as values for x increases, values for y also increases, like that. So if x and y have a strong negative linear correlation, R is close to -1, and R value of exactly -1 indicates that perfect negative correlation. Negative value indicates a relationship between x and y, such that as values for x increases, value for y decreases. Now moderate positive correlation, that ranges between 0 to 1, right? Similarly, moderate negative correlation may range from -1 to +1. And again you can see the graph which clearly depicts that. Again there is a further graph on that, makes it more clearer. This again is a positive correlation, negative correlation, then no correlation. So again there are various, because graph is very useful, and just by looking at the graph itself one can make out that yes, whether there is a positive correlation or a negative or a no correlation or whatever, how it is depicting, how is it presenting it. So if there is no correlation or weak linear relation, R is close to 0. A value near 0 means that there is a random or a non-linear relationship between the two variables. Now, Karl Pearson's correlation coefficient, there are two types of correlation coefficient. One is Karl Pearson's and the other is Spearman's rank correlation. Now, these two people have created the correlation. Now, let us try and understand with an example now. Now, first let us import the libraries and the data set to be used in this exercise. Now we talked about the pandas and numpys, etc. Now we are going to use it as it is shown here. So import pandas as pt from scipy stats import norm. Now here you can see that scipy, there is a stat is one particular sub library of the scipy, and from sklearn you are using pre-processing import min max scalar. Now these are all sub directories, sub libraries. Import matplotlib.pyplot as plt and percentage matplotlib inline. Now when you are going to write your codes, you will be writing something like this only. Import seaborn also as SNS or SB, whatever you want. Then you can define your data like pd.rate. Now once you have defined the pandas, you can define the your data frame, which is depicted as df is equal to pd.read underscore csv, because you are using csv data files, and the location wherever your data file is, and then house price dot csv, because it is a csv means comma separated values, right? So before we start working on the data, let us first understand the data structure and the contents. Now the details of the data file, house price dot csv are sale price, the property is sale price in dollars, then ms subclass, the building class, then ms zoning, the general zoning classification, lot frontage, linear feel of a street connected to property, then lot area, lot size in the square feet, street type of road access, alley type of alley access, lot shape, general shape of property, land contour, flatness of the property, utilities, type of utility available, and lot configuration. So you can see that it is very important that you must be very intimately knowing about your data file. What is the data that you have and how you are going to use it. So the knowledge of that or intimacy with that is very important. You can check it with this, like let us check the data by displaying top 5 records, and that can be done with the help of df.head. So once you write and run this, you can see that top 5 records can be displayed on your screen. Now let us also check the shape of the data and how many rows and columns are there. That also is possible. So you can again write df.shape, and you can see that a number of rows and columns are shown on your screen. We should also check the summary of the data, like df sale price dot describe. So you can see that again you are getting all these summary details: mean, standard deviation, minimum number, 25 percentile, 50 percentile, 75 percentile, etc., etc. So all that is available. This is known as data exploration, which is very important for the developer or the person, the user, that he must know that what is the data like, and then only he can go for various computation that he wants to do. The following code may be written to check the histogram that will create it with the data set. This histogram shows how many houses are sold at what price. Now you can see that is also so simple. PLT figure, fixed size is 9.5, that is the total size of the graph that you are going to have. Then df sale price dot plot kind, that is what is the type of graph that you are going to have, which is hist means histogram, and then the moment you execute it, you will see this kind of a graph. So it is very simple. In fact, when you are going more into details, you will see that how easy it is. So this is the way you can see that what are the various houses which were sold at what price. Now this is another, this is known as heat map. Now let us now draw a heat map that will be created with the help of the following code to get correlation matrix. Now correlation we have already discussed, so correlation matrix can also be created, and that is df.corr, correlation. Grid correlation matrix, f comma ax is equal to plt subplots. You are going to create a subplot. Fixed size is 9.8, that is again the size of the graph. And SNS was the seaborn that you have imported. So SNS dot heat map, then correlation matrix ax is equal to ax cmap. Cmap is the type of color combination that you want to have. Now here we are having yi, gn and bu, that is yellow, green and blue. You will understand all these things when the more you go through into details. Then line width is equal to 0.1. That is how when you run it, you can see that this type of a heat map will get created, and this definitely is very, very helpful. You can easily understand that how the various data points that you have are depicted on this graph. Let's now draw a cluster grid. To understand the cluster groups formed with the data by having a dendrogram, top of the correlation matrix as shown in the plot. You can see that on the left side of the graph, which is in green and blue, you can see a like pencil lines, which are nothing but the dendrograph. Now this dendrograph is something which is again very useful. So how this gets created? CG is equal to SN dot cluster map correlation matrix, C map, again the same color combination, line width is equal to 0.1. Now PLT dot set P CG dot A, this is the command, of course. This the more you are going to write it, you will get to know about it. So y-axis dot get major tick labels, rotation is equal to 0, and then when you write CG and then execute it, you will see that this kind of a graph is going to be presented to you. So let us now try to find the correlation, the sales price and the number of variables being considered. Thus we get a correlation matrix between the sales price and K, the number of variables that will be presented in the heat map with this code. So import numpy as NP, then K is equal to 15, columns is equal to correlation matrix, enlarge K sale price dot. So this is the code. So right now I think it is difficult for the beginner to understand, but once you go through this time and again, or maybe you can write some programs, and then you will definitely start become very comfortable with all that. CM is equal to NP dot correlation coefficient, DF columns, then values T, and the further code on subplots, then SNS heat map, etc. And then once you execute it, you will see that this is the kind of heat map that you are going to get, and which is very easy to understand. You can see that how informative it is. The entire graph, every block is very informative, and one can definitely draw his conclusions from this. Now looking the heat map, we can easily understand the correlation among different variables. We can see the correlation between two variables. Similarly, depending on the value mentioned in the square, we can conclude the correlation between the coordinates of that particular square. So you can see that again. Now here you can see that different color combination is possible. So all that is possible because you can keep on changing the colors and see that whatever appeals more, you can use that. Then like correlation between sale price and overall qual is 0.79, sale price and greater live area live area is 0.71, etc. So this is the kind of a correlation that you can have. Thus we can calculate the relation between various variables, and you can see that these are the different graphs which can be created with different sets of variables. So this completes your correlation, and this correlation is again a very useful option available in Python, which we can use and understand that how these two variables are related. So that completes your correlation. Thank you.